So today I'm going to discuss very important things in RSTP. So now you will understand how actually RSTP works. This is the basic information yesterday I have given, like what is the port rules, state, and other things. But now I will explain like how port conversions work, because main important thing, the port conversion. Once any port is blocked or disabled or whatever, then how it will become a root port and start forwarding the traffic. So those things we will discuss, because once you will understand like how we are going to convert the port from blocking to forwarding, then you easily compare with STP. Okay, because 99%
Mhm.
cases you will see like they will ask the question how what is the difference between STP and RSTP, right? And yesterday only
Mhm.
I got the question like one of the person was giving the interview. So he first question he asked like two question he asked in the switching. The first question was,
Mhm.
what is the port fast? I explained already.
Okay.
So and second question asked by preemption. What is preemption? You don't know preemption? I because I have not explained about the HSRP, which is most probably last
Okay.
topic of switching. I will
Okay.
explain. So port fast you already know, right?
Right.
We are going to enable on the end user. I will explain again. End user connected PC.
Port,
Here also we have
end user port.
end user port, and it's not going to
Mhm.
follow the HTTP states. As soon as we will connect
Yes.
the computer or system, it will put that port into forwarding state immediately. That
Mhm.
information you have to give once someone is asked what is the port fast, right? So these are simple questions sometimes they are asking, and he got selected as well for first round. So next round might be in Monday. So we are discussing on. Anyway,
Um,
so you learn whatever we are discussing. So it will be very helpful. You will think like once you will start giving the interview, then you will feel like yeah,
so
what
in port first will be saving 30 seconds, right? Because there will be no
yeah,
learning
right,
and no
right, right,
listening. Mhm.
right. In RSTP, you can see 15 seconds is already gone because we do not
Mm.
have a state like listening. We have learning.
Listening, right?
Okay, so 15
Mm.
seconds gone, right? Only 15 seconds is
Yeah.
remaining. So 15 second also how it's eliminating, I will explain here. Okay.
Okay. Okay. Okay. I
So
got it.
first of all, like if you remember, we have three types of topology change in STP. First is insignificant change. Second is
Mm.
direct topology change.
Direct,
Third is
indirect.
indirect topology change, right? So we learn
Yes.
STP. In STP, like you have seen insignificant change, like where end user port was going down and switch is generating the TCN, right? But here there is
Yes.
no TCN in RSTP. And direct topology change, you are saying like we have a solution as a uplink fast, but here
Why
RSTP
there
you
is
learn.
why
Mhm.
there is no TCN in RSTP?
It's a design like that to make topology
Okay.
conversion fast. Okay.
Okay.
Yeah.
I should
So
know
like that,
this.
I will explain one by one. First, you can say uh, insignificant. So same is same like STP. We are also using the port fast to solve the insignificant change. Okay, but let me explain bit like how STP actually works. Okay, then you will
This
understand
comes
more.
under insignificant topology, and this is under RSTP, right?
Right? Is this is under RSTP. So
RSTP.
we have a port like that, right? Switch number one, switch number two. Okay. So what in that once switch will come up, right? Once it will connect the cable and switch came up into, like how it's like came up means it's powered on. I mean, okay. So both device earlier in the STP and other protocol, STP only, we are sending the configuration BPDU to each other, right?
Hmm. Right.
Like that only, but here we are sending the proposal message. Means this is also proposal message. This is also send the proposal message. Okay. So those will compare their router, root bridge ID. So lower root bridge ID will become a root switch. Clear? First, one switch comes up, then they will send the each other that proposal message configuration BPDU, and they will decide which switch will be a root switch because they will compare priority and MAC address, right?
Hmm.
And once it's confirmed, then they will decide the root switch. So let me write once switch will come up. Will and decide the root bridge, right? Means in the proposal message themselves, they keep their root bridge ID. For example, this switch is sending some root bridge ID, this switch is sending some root bridge ID, and they will compare and decide the root bridge. Clear?
Yes, clear.
Hmm. Okay. Once switch will receive the superior BPDU inside the, proposal message, superior BPDU on the port. Then here port fast actually you will understand how is required in the Rstp. One switch will receive the superior BPDU, right? For example, here we have two switches. Okay, here we have two switches, and they will send the proposal. They will send the proposal, and they will decide the root port. For example, this is root port, right? Here we have some computer connected. Some computer connected. Here we have also some computer connected. Here we have also some computer connected, right? One superior BPDU received here and here, whatever. And apart from those ports, okay, all the port will be in discarding state. Discarding means blocking. Discarding means blocking. Blocking, then listening, then learning, then forwarding, kind of, right? So discarding means nothing. Means like these port are elected as a management port, for example, root port and DP port, whatever. After that, all the port will be discarding state. Means discarding means those are the end user port. Okay, and end user port will be discarding. After that, they will uh, you know went into listening, learning, and forwarding. Okay, here is a learning state. Learning state and forwarding state. Two state will go. At least 15 seconds spent here. Okay.
So basically, until they select the route bridge, all of this port, I mean, apart from the management port, other ports should be in the discarding state, right?
Huh. Yeah. And discarding state
Okay.
also will take 15 seconds. So 15
Okay.
discarding and 15 learning. And then forwarding means 30 second also it will take, right? So
Okay.
so as those are the end user, then we can enable the port fast, right?
We can reduce this 15 seconds, right?
Yeah, 30 second to 0 second, right? As soon as we will enable the port fast, then discarding state, whatever is putting in discarding and
Okay.
spending 15 seconds, then learning, then forwarding, right? So what we will do,
Okay.
we will enable the port fast. It's recommended to enable the port fast once you are using the root, rapid spending tree protocol. Okay.
Okay. Okay.
So you need to hold on. Let me.
I need to note this, write this down.
Okay, sorry. I have deleted it, but let me know where I need to stop so you can read.
Mm,
Write somewhere. Once it will
just
receive
need
the
to write
superior
this.
repeat on the port, and
Mm,
after that, after that, all port, other ports will be in discarding state. And in discarding state, which will take 15 second to move to learning. Clear?
yes.
And this entire process we are calling as a synchronization. Means this one, above process we are calling as synchronization. Got it? Means above process means once root be selected, and then all the port will move into the discarding state. And these two steps we are calling as a RSTP is synchronize, and this will happen very quick. As soon as the RSTP is enabled, you will see like it's happening very quick within a second. They will identify the loop, they will block, and then they will do everything. Okay.
Mm.
Okay. So once this port, for example, this port and this port, right? This switch we have, right? This is sending agreement. This is receiving agreement, right? Once sending and proposal accepted. Once proposal accepted, then both the ports will become immediately in forwarding state. Earlier, it was like checking the loop and all those things, right? It was taking
Mhm.
approx 30 seconds to become any topology. For example, I will show you here. Let me log in. Let me stop recording because of I'm putting my email ID. Stop sharing. So, able to see my screen?
Yes.
Okay. So means root port will send the agreement and DP port will receive the agreement. So both the port will become a forwarding state immediately. So earlier, for example, you are putting as a two switches here, okay, and you are connecting the cable here. For example, you are connecting the cable here. Now see, it is taking time, right? It's taking time because they are not putting immediately into forwarding state. If you will see a spanning tree, for example, in a spanning tree, so a spanning tree, see, it is a listening state, right? But they are not going to that process. They are sending the agreement message, and once agreement is received and they agreed on that, after that, it port will become immediately in forwarding state. Okay, see, it's taken approx 30 seconds. It's not like that. If road port is sending this
Uh,
one information, huh? Tell me.
okay.
Do you want me
To
to
have
prove
just connected
prove
the
that?
switch.
Yeah, let
Mm,
me try to prove that. I am never done that, but I will try to prove that. I will enable the first RSTP, and then I will connect the cable. Enable config T. Then how we can enable the spanning tree? How we can change the mode? Spanning tree mode. Then see RSTP rapid. You need to rapid PBST.
mm.
Here also you need to write the same. Enable config T uh, spanning tree mode RSTP. Then so in that case, connect the cable. Came immediately.
Yes,
Correct. Disconnect the
right.
cable. Disconnect the cable. Okay. I'm just putting in simulation mode. Okay. Let me see what are the messages. It's coming. STP, STP. There is
On the second one, third last. Yeah, second
okay.
last.
STP. Let's connect the cable and see what messages. See, eh? Immediate it came. Uh, ah, let's remove this. Just take another example. Then I will. Uh, we have kind of. Let me see if we have STP as well. RSTP. PBST we have seen. PBST. No, right?
HRSP. There's HRSP.
PBST is not there. Let me try if I can connect the cable again and see. Immediately it's putting that. Okay. Let me entire earlier it was taking some time. Might be I can see the packet. I'm not sure I can see, but let me try again if possible. Two switches and enable the spanning tree. No. Okay. So enable config tree, spanning tree mode, rapid spanning tree, rapid PVST. Here also just do the same. Give me a moment. Give me a moment. Okay. So let me see. If I open the simulation mode and enable the spanning tree, I enable the both the switches. Okay, not here. Spanning tree mode, rapid spanning tree. Done. Let me see if I am connecting the cable now. Oh, immediate forwarding, man. The rapid spanning tree, RSTP 1W. As I explained, a rapid spanning, lot of information, flag information, and everything is going on. And LLC, this is the layer 2 header, and then Ethernet header. Here is Ethernet header. Source MAC address distance. So means my mean is like we no need to wait any single minute or single second or something, right? Port is coming immediately in forwarding state. Agree?
Yes.
Okay. Now this is one thing is proved. Now end user is putting, as I explained, end user system is going into discarding state immediately, right? For example, if you will connect the PC, so here you will connect the PC and you will see here in initially you will see like so spanning tree. So these are the blocking. See, as of now is a blocking state
Okay.
means discarding state
Hmm. Yes.
and discarding to forwarding. Discarding, then learning, then forwarding. Okay. So it's approx taking the 30 second you can say approx 30 second. But what is mean like we need to enable the port first to prove that. Now you just same meeting you can join. Okay, above synchronization, then root port will send the agreement and receiving port will become in forwarding. Means root port will send the agreement and this agreement and receiving port will become a immediately in forwarding state. Means this is what is mean actually. Means root port is sending. Root port is also in forwarding state. That's what is we are calling as a root port, right? They send agreement and receiving port also will, as soon as they will see the agreement message, that receiving port also receive the message and will become a forwarding state immediately before without following the spanning tree states. Okay. Then this is mean of this statement state. Now for discarding ports will take 30 seconds to become into forwarding state. To reduce this time We are enabling the port first. Done. Write the statement. Let me know if any confusion.
Just give us a minute.
Sure, sure.
I have one question.
Mm-hmm.
Uh, like like you said, like a root port will be sending the agreement, right? This
Right,
agreement message or whatever,
right.
and the other port which
Other
would
port
be receiving
maybe
that.
DP, you can say.
Yes, yes, that's what my question is. Other
Mm.
port can be DP or
DP.
it should be DP only, right?
Yeah, it should
There
be
could not
DP.
be other port.
It will,
Yeah,
yeah, correct.
right.
It will be DP only.
But my question is why the root port would be sending that?
That is only the path in the switch, in
Hmm.
non-root bridge switch having, which is going to communicate with the root port. Means you learn when I was discussing about the root port. What is the root port? So we are saying
Uh,
like it's shortest path to reach the root switch. And
right.
only in all the segment, all the switches, I mean non-root switches, each switches will find single port that is the root port. And root
Hmm.
port having low cost and receiving the sending the superior BPDU from that port because a lot of other port are sending, but that port is sending the
Okay.
superior BPDU. That's what
Okay.
that port
So
become a root port, and that is the port which is responsible to send all type of communication, all type of traffic to the root bridge.
So my question was because the port which is assigned as DP, right? Like for example, the root bridge or both the ports, all of the ports which are with the root port are all DP port, right?
Correct. DP port, root port or
Right,
blocking port.
or blocking port. But generally, I'm just saying like if there's a root switch,
Mm-hmm.
then all of its port would be in DP
Right.
port, right?
Right.
Right. But my question is like if that switch is decided as the root switch, then
Uh-huh.
why won't it be sending the agreement message to the other switches that I am the DP port? So I should be sending and others should be receiving. That's my confusion.
They decided in agreement, right? First they have
Uh,
exchanged the agreement and decided
uh,
which priority, I mean, as I explained here, one
mm,
switch will come up, switches will send the proposal message,
mm,
proposal will be sent to each other, okay, and decide
mhm.
the root bridge. Once the root bridge decided, then
Okay.
other switches having the option only send the agreement, I mean root port, I mean what we are calling as a agreement to become uh, to identify, to say like I am a root port, kind of.
Okay. It's clear now. It's clear now.
Yeah, like that only. So
Okay.
first is the decided who is the root, and in the same message you can say as a root port also decided as bridge decided, right? And they are
Mhm.
claiming, each and every switch is claiming like I'm a root, I'm a root. So which port is sending, the superior BPDO, they will become immediately as a root port, and it will become into forwarding state immediately without going like all the steps and all. So that's what they have introduced to message like a proposal and agreement. So by using those messages,
Mhm.
they are making sure that topology is loop free, and they can decide the root port and DP port and root trees and discarding state as well.
Okay.
Discarding means nothing but is where none of user is connected, all the port will become as a discarding state. And end user port you can say, which is not connected to like they are not sending the agreement and they are not receiving the proposal kind of, right? Because end
Right.
user will not send, never send the proposal messages. That's what they will put all the messages into the all the port into the discarding state. And which is remaining, they will send the agreement messages.
Mhm.
And which is receiving either DP or other port, or might be the other switch having also the root port, for example. They are sending that. So a lot of
Okay.
topology, for example, is connected like that.
Mhm.
They're connected here, 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 like that.
Mhm.
They will send to him. This it will send agreement. This will send to here that agreement. Those agreement which is sending is a root port. Which is receiving, it will become a forwarding state. Port is role maybe DP most probably. In case not DP or something, but it will become a
Mhm.
forwarding state. Which is sending, which is receiving agreement, that will become forwarding state. That is our mean. Means we need to make the topology come up immediately as soon as possible.
Mhm.
So they are introduced two messages. Clear?
Mhm. It's
Means you
clear.
can say which is port is sending the agreement, which is receiving, those will become a immediately in forwarding state. And root bridge election will be happen by sending the proposal message like BPDO.